Okay, ladies and gentlemen, we're going to wrap up this unit with some discussion about quadratic systems and quadratic inequalities. The first type of quadratic system is actually one quadratic and one linear equation. So we're talking about a parabola and a line. And you need to think of the graph as all of the points that make the equation true. So if we have all the points that make the quadratic true and all the points that make the linear equation true, we're looking for where those two graphs cross, which would be the place or places where those places make both equations true, those xy values. So there's a couple of possibilities. You could have a parabola and a line that never touch, or you could have a parabola and a line that cross twice, or you could have a parabola and a line that cross once if it just happens to rest right on the line. But I think that's pretty much our only options here. We're looking for either 1, 2, or 0 answers. So the first way we're going to find those answers is through substitution. Do it the algebraic way. And then we'll look at a picture of the graph and confirm what our answer said. Now when you substitute, this sets up nicely for substitution because the linear equation is already solved for y. So I'm just going to take what I see here and put it right there in place. So my equation then is 4x plus 4 is equal to x squared minus 5x plus 18. Now this should look familiar. This is a quadratic equation that we've been dealing with for a while now. Any quadratic equation hopefully will solve through factoring, if not the quadratic formula, but the first important step is that it equals 0. So I'm going to move the 4x over, subtract 4x from both sides and get negative 9x on the right. And I'm going to subtract 4 and get 14 on the right. Okay, so now this one looks like it's going to factor, I believe. The 14, I need two factors of positive 14 that add up to negative 9, negative 2, and negative 7. Which means the x values of my solutions are 2 and 7. Now, that means, so far what I know is this line and this parabola should be crossing when x is 2 and x is 7. So if I had a graph here at 2, somewhere along this vertical line is going to be one of my intersections, and there along that line at 7 is going to be my other one. Plugging this value, these values of x into either equation will tell me the height of those two intersection points. So I'm going to plug them into the linear equation because it's easier than plugging them into the quadratic equation. So at x equals 2, y equals 4 times 2 plus 4, or I need those. 8 plus 4, or 12. And then at x equals 7, y equals 4 times 7, 28, plus 4, 32. So my two solutions, remember to write your solutions as ordered pairs. 2, 12, and 7, 32. Okay? These are solutions because they are xy points that make both the equations true. There are infinitely many points that make the quadratic true. There are infinitely many points that make the linear equation true. These are the two out of infinity that make them all true, make them both true. Okay, so that's method one. We can also solve these things by graphing. In graphing a quadratic and a straight line, the system, it's not the easiest thing to do by hand. You could do it if you had to, but usually we graph our quadratics by picking some key points and then just kind of filling in the rest. So it's kind of hard to make it accurately. Sorry about that, my microphone died. But I was saying if you're going to solve this thing by graphing, it's hard to get the graph perfect. So I'm going to graph it in my calculator for the sake of time and to get it perfect. If you type into your y equals equations, I've got the first two highlighted. That's the system we're working on right now. And then graph. My window's messed up from a previous graph I was doing. Anytime you need to get back to a regular window, hit zoom and then 6 for zoom standard. And we should be able to see our graphs. There's our line. And now my parabola is missing. So I might either need to zoom out or just kind of adjust. If you look at where our solutions are, they're at 212 and 732. So basically I need to move up in my window to see where the graph is. So I'm going to go to window, and instead of y going from minus 10 to 10, I'm going to make it go from, I don't know, I didn't even see it at all at 10, so I'm going to make it go from 10 to 25. Just give that a try. There's my parabola, and here's my line. I can see one of my solutions, but I might even need to zoom up some more. That one answer was 32. That makes sense. So let's go to 40. I'll make sure that I capture those intersections. Okay, now I can see them both. So if you want to find intersections of graphs in your calculator, go to Second Trace, which is the Calc menu. And there's a lot of things that this calculator will tell you about a graph or graphs. I'm going to choose option 5 for intersect. Where do these graphs intersect? Now it's going to ask me 3 questions. First curve, just hit enter if you just have 2 graphs on there. Second curve, the cursor is on the line somewhere. I'm going to hit enter. And then guess means put your cursor close to the intersection. Move left and right. The cursor moves down the graph, just to give the calculator a place to start looking. So I put it down close to that first intersection, and I get 212. And then quickly the second one, second calc, option 5, enter for first curve, second curve. Now I want to move up closer to that other intersection, so it'll find that one for me. And there's the 7 and 32. Okay, so that confirms my 212 and my 732. All right, next, quadratic versus quadratic. So this is going to be 2 parabolas, the intersection of 2. And this has a couple of options as well. They might never touch, they might cross once or twice. So let's just see how this one goes. Okay, so same deal. I've got 2 equations that are both solved for y equals. So basically all I need to do is set those 2 equal to each other.